Hello everyone, I am Anshul and I welcome you wholeheartedly to this session. I hope you're enjoying the subject till now. Today, in this session, we will be talking about a new chapter, which is friction. So tell me, what is the first thing that strikes your mind when you hear the word friction? Is it something related to motion? Is it something that opposes motion? There are many people in this world who actually believe that friction is something that opposes motion. Do you agree with them? Let's find out. So, by definition, friction is a force that opposes relative motion between two objects kept in contact. Remember, it's the relative motion which is being opposed by friction. There will be many cases in which friction will be opposing motion of an object, and there will be many cases in which friction will be actually supporting the motion of an object. We will be talking about these cases in detail in coming sections. But what I want you to remember is that friction has nothing to do with motion. It may oppose the motion of an object, it may also support the motion of an object. That depends on the condition and situation. Right? So, basically, friction is something that opposes relative motion between two objects kept in contact. Remember, contact is equally important. Right? So, before going further, let's first remember the major takeaways from the definition of friction. The first and the most important one is friction opposes relative motion between objects kept in contact. Second, which is to correct the misconception that friction may support motion or it may oppose motion. Right? It has absolutely nothing to do with motion. In fact, friction is apathetic towards the motion. Okay, now, before going further into details of friction, let's first talk about types of friction. So basically, friction is of three types. Number one, static friction. Number two, kinetic friction. And number three, rolling friction. So we'll be talking about rolling friction in detail in a chapter named rotation. Right? In this chapter, we will be talking about two types of friction, static and kinetic. Right? So, let's first have an idea about kinetic friction. So, kinetic friction is seen when two objects kept in contact are moving relatively. That means there already is a relative motion between these two objects. Right? So, there is friction which is trying to oppose the relative motion. It may stop the relative motion after some time, but at this point of time, there is a relative motion and there is friction. This friction is unable to stop the relative motion. It may stop it after some time. So this type of friction, when the relative motion is actually happening between the two surfaces kept in contact, is called as kinetic friction. Whereas static friction is seen when there is a tendency of relative motion, but the actual relative motion is not happening. Now, what do you mean by tendency of relative motion? So, tendency of relative motion means there are two objects kept in contact. There is an external force which is trying to move this object relatively. But the two objects are not moving relatively because friction is strong enough, it is powerful enough to stop that relative motion. It is strong enough to counter the external force which is trying to create a relative motion. This type of friction is called as static friction, which is not allowing the actual relative motion to happen. Right? So, static friction is seen when there is just the tendency of relative motion, but the actual relative motion is not happening. Whereas kinetic friction is seen when the actual relative motion is happening. Now, the concept of static friction is very important. In many competitive examination, concept of static friction is a frequently asked one. So, let's try to understand static friction with a day-to-day example. Right? So, let's see that you have a huge object in your home, right, which is very heavy and it is kept on the floor. like a sofa set or a used table or a fridge, whatever it is, but it is heavy and it's kept on the floor. Now, there's a child here who goes near to this object, this heavy object, and he tries to move that object. Let's say he's trying to move that object by applying a force of 5 newtons. But this object is not moving. So, by Newton's first law, if the object was at rest and it is remaining at rest, that means the net force on that object should be 0. So, if I am applying a force of 5 Newton in this direction, still the net force is 0. That means there has to be a force which is countering my applied 5 Newton force. And that force is basically the force of friction, which is between the floor and the heavy object. So basically what is happening is that there is a force of 5 newtons and there is a friction force which is in opposite direction. Right? So the net force should be 0. Therefore, the applied 5 Newton force minus the friction force should be equal to 0. Hence, the value of friction force is 5 newtons. I hope you would agree with me. Right? Now, let me change the situation. Let's say the child is now tired. He cannot apply a force of 5 newtons. But he didn't give up. Right? He was stubborn. But what he is trying to do now is that he is applying a force of 3 newtons. He has reduced the force because he was tired. Now, imagine the situation in this case. Let's apply some Newton's law in this case. This time, the object did not change. Remember this, the object did not change, the flow did not change, the child did not change. The force, the applied force which was trying to move the object, only that changed. So what I basically have now is that there is an object which is very heavy, and that child basically is applying a force of 3 newtons. Right? There is friction force between the floor and the object. We have talked about it. So let's say I am assuming that the value of friction force did not change. Right? Why am I assuming this? Because the flow did not change, the object did not change. Right? So I'm assuming that the friction force did not change. So the value of friction force from the previous section, from the previous case, was 5 newtons. Now imagine this. There is an applied force of 3 newtons in this direction, right? And there is a friction force in this direction, in opposite direction. The applied force is 3 newtons and the friction force is 5 newtons. That means that this object will have a net force of 2 newtons in backward direction. Now, according to Newton's first law, if there is a net force on an object and is kept at rest, then it will have to move in the direction of the net force. Right? Now, imagine the situation in this case. When the child was not applying the force, he was applying a force of 5 newtons in this direction, the object did not move. But when he reduced his force to 3 newtons, the object started moving backwards. Imagine the situation of child in this case. He would be frightened. Obviously, there has to be a mistake over here. This is not what is going to happen. So, what is wrong with it? My assumption is, we know this for sure, that if the object did not move when the applied force was equal to 5 newton, then the object will surely not move when the applied force is 3 newtons. So, when I am applying a force of 3 newtons, what will basically happen is that object will remain at rest, and for that object to be at rest, the net force on that object should be 0. So, now let's do the maths over here. I am applying a force of 3 newtons in this direction, and there is a friction force in this direction, so there are 2 forces basically, friction force in this direction and 3 newtons force in this direction, right? And the net force is 0. Therefore, what I can say in this case also is that 3 minus the friction force will be equal to the net force, and this should be equal to 0, right? And therefore 3 minus friction is equal to 0, or friction in this case is equals to 3 newtons. Now imagine this, right? The flow did not change, the object did not change, but but the value of friction got changed according to the demand of the situation. This is the basic property of static friction. The value of static friction is not fixed. It will change according to the demand of the situation. Right? In case of static friction, you will have to find the value of static friction according to the situation. Isn't it wonderful and interesting? Physics is full of these type of concepts. I will be talking about many concepts like this in coming sections. Right? Till then, happy physicsing.